what are we all doing here? What are we fighting for when it comes to blockchain? What's the point, and what are the table stakes?
Man, you didn't start out with an easy question. The problem is I say it's not an easy question because, in my opinion, the table stakes are pretty dire. It's not just about, to me, blockchains. Yes, it's great that we, the start of Bitcoin was focused on like financial inclusion and making sure that people could kind of have a voice in their own financial, freedoms and being. But overall, I really think that the table stakes for blockchain 10 years later, or 13 years later, I guess, is much more about like trust, like human trust in like the digital era. We really, like, in my opinion, the internet is like ripping us apart, right? We've only had it for, really like Web 2, right? The last 20 years or so, 15 years. We've really only had web for maybe 30, right? Maybe as long as maybe 40 if you want to argue ARPANET and all that stuff. But it just seems like as we just keep making these steps, and people just keep finding better and better ways to, like, I don't want to say entrap us, but it's kind of like they just, like, people figure out how to manipulate us and figure out how to like play on those patterns that just exploit and just do the age-old thing of enriching the people who have a better, or who are just like got there first, and doing that at the expense of others. And I really think that, I hope that blockchains and distributed technologies are equivalent to like the signing of the Magna Carta, right? That is the way that we can, instead of having open loop economic systems where as participants, as like the folks, the people who actually live our lives, right? Instead of just like putting money into like the black box of our economy, we actually have insight, and we can, adjust our behaviors and our expectations, on a very short cycle, and not these like year-long cycles of oh, maybe we're in a recession, maybe we're in a bull run, and like we never really know where we're at. And like, I don't know, that seems like a problem, and it seems like that lack of knowledge, that lack of insight for like the common folk is a way for people to take advantage of us. And like I said, my personal opinion is that blockchains, I've said for a long time, if anything has the potential to do it, blockchains hold the greatest potential in the 21st century to revolutionize the individual's relationship to trust in society. So it was a very long-winded answer, but like I said, you didn't start off easy.
That's exactly what I'm looking for. It's that's what we want to put on the table here, because I think, and you can maybe talk a little bit about this more, because you do get in front of a group of students to share what is the why. We can't necessarily start with this is how the blockchain works and go into the technical details. If we start why, and with the unique selling proposition, or what is the disruptive innovation that exists here within blockchain, that is the thing that should attract more people and more attention and more resources. And that's something that I think has been highlighted, at least when doing my research on Topl, was that if you remove all of everything else, what is the thing that it can do that nothing else has been able to do before? And that's trust and direct participation. And that seems what you're interested in from a human level. And then that's what you're interested in from Topl on a professional level.
Very much. One of the things you mentioned students, and so I've been teaching this an introductory class for the last 3 years, and it's I don't know, it's weird. It feels like we're just getting that first generation of like people who have been around and like kind of learned blockchain the hard way and are now starting to, teach the next generation. I would say we're maybe a little bit into that, like the creation of the second generation. But one of the things that I learned really quickly was that I actually tried, like you said, I understand things by breaking them down to their smallest, like atomic components. Like my training is, I have a PhD in ultra cold atomic physics. So like I really like people hear atomic and they think high energy, and it's like, no, I'm literally the opposite. I am like the smallest, slowest, simplest physics that can ever possibly exist. That is the only physics that I'm good at, or like know or can understand. And people are like, oh my God, wow. It's like, you don't understand. Like, I'm really bad at physics. I'm just a really hard worker and a good experimentalist. Like, I can understand machines. Um, and but so like that just it I always felt like pulled, or like I found a deep interest in like understanding the constituent pieces of things. And so when I got into blockchain, I tried to do that same thing. I broke everything down. I tried to really understand what are the main pieces I need that I can't break anymore, or can't like further atomize or make primitive. And then I tried to teach it that way, and the students they had no idea. They would just glaze over, and they were just like, "What are you talking about, man? I'm here to learn about like Bitcoin and Ethereum, and you're just telling me about, consensus and BFT algorithms and transaction and all this stuff." And it's like, I realized this past semester that I actually came in. I decided, I was like, "Oh, look, let's just come in at an example. Let's come in at something that you've probably heard about, and I'll tell you how it works, and then I'll use that example to motivate why you should understand all these smaller parts, and then we'll use that taxonomy to then kind of step out again and say, now we can look at Ethereum and Cosmos and Polkadot and all the newest blockchains." So yeah, I really think having that idea of you have to be able to, if something is always a why, what, and a how, it's really hard to get people to delve into the why, even though that's the thing that drives you. It's really hard to communicate a why sometimes. Right? It's much easier to sometimes start at a how or a what, because people connect, they see those things more often. But the why is really what drives. And one of the things I really would always tell my students, I was like, look, this is going to be, I co-teach the course with a business school professor. And so he takes a very like application oriented approach, and very much like why our business is interested in this. Whereas I take a much more like, you should understand the threshold test of what proof of work is, right? It's just a hashing thing, and so we go into like the technical details, just to understand at a high level what it means to do proof of work. And I tell them, like, I'm not going to quiz you, or like, you don't need to go do a proof of work algorithm for me or something like necessarily, but you should be able to understand enough that when someone says that this system can do X, Y, Z, you should be able to think and say like, oh, but what about the A or B? And if they can't answer that problem, or if they can answer that question, then you've that's bad. You should always be able to answer at least one level of questions. And I went into this whole diatribe to say what I found in like presenting them with that and saying like, this is, I think, a useful way to approach people or learning about these systems, is at the end of the semester, they were really into like investigating frauds that have happened in the space, and actually talking. I even had one student, I think she mixed up two of the assignments, and she actually told us how the fraud happened, and then she told us how you could have prevented the fraud. I was like, great. I appreciate that you told us that, but you don't have to share with us how to be a criminal. But that goes to say, like, people do really want. People have such a desire to like, just not. I don't know. They just feels like it's like this yearning. Why do people trust fraudsters, or why do we give away our trust so easily? Yeah. And so that's a very hard question. I don't know how blockchains I think blockchains may be the mechanism to solve it, right? They may give us a way that people can actually do what's naturally they want to do, which is trust, but they can do that in a structure that doesn't then leave them vulnerable to people taking advantage of them. So I hope that they got that, or, I share that with the class, but yeah, I mean, actually communicating the value of why
I can totally see that direction.
Accountability and like transparency in these systems is, one, is needed, and two, is hard to achieve, is a ginormous undertaking.
James, can you hear me? So, James, you jumped ahead just a bit on me, because I did in my research, I saw an interview. Actually, this is a written interview with Chris Georgian, one of the co-founders of Topl, and he said something along the lines of, so uh, he said, one of the strongest CTOs in the blockchain space today early on asked me to let him leave the company because he didn't know what he could contribute. Saying no to this and working with him and grew as he grew into the technology leader is among my proudest accomplishments at Topl. And so you do have a PhD in atomic and molecular physics from Rice. So what are you doing here? And what was he referring to you? And what was that feeling that you weren't sure about that you feel like you are more sure of now?
You know, the scariest thing. I'd love to share that history, but I actually said this the other day, and or in a talk that I was invited to give about the UTXO Alliance in Edinburgh. I actually said that I remember the moment where I realized that why UTXO smart contract systems were problematic. And in telling that story, I was like, I probably was a little over my skis when I first joined, when I first came full time into Topl and was really trying to learn blockchain, because I had never, I've never participated in software development. I've never, like I said, all of my training is in physics. And so that was a really hard thing for me to learn. And I think it has been a trial by fire somewhat. And then especially being in the middle of the country, without a whole bunch of, or we don't have this, that what's the word I'm looking for? Network. That I'm trying to think of that cohort. That's what okay, I'm gonna go back. Yeah. Well, I want to say like foundation seed, but I can't think of the right word right now, so I'm just gonna go back and say we don't have that cohort because we're good enough. Yeah. So especially being in the middle of the country, we didn't have a good cohort of companies or people doing the same thing, because they're very much on the other two coasts, and we're on the third coast. So we got to make the third coast of the U.S. a thing now. That's what I'm going to try to do. But that just led to basically we were asking ourselves all the questions that pretty much everyone had asked themselves a few years before in groups. But I didn't have that knowledge and those people to ask and learn from. So I just kind of figured it out myself. And I think it really helped us, because it means that we started from square zero and had to it's taken a long time. We've been around for 5 years, but really the last 3, since at the end of August 2019, I came on full time. And since then, it's just been, a rocket ship. We have done so much since then. I literally, the summer of 20, rewrote from version 0 of our blockchain to version 1 of our blockchain. And then we're now working on version 2 to be released next year. It's a version 2 of the network. And I was to say, I know I'm going to get back to the original question, but the first time you write something, you don't know what you don't know. The second time you write something, you know what you don't know, but you don't know how to use it. And the third time you write something, you know what you didn't know, and you know how you want to use it. So usually the third time's, deployable or sellable or actually useful. So I think it's a benefit that we've taken our time in doing this and trying to do it not be so fast. Sometimes the bear markets have helped. I'm hoping that this will be the last one we really have to be in obscurity for. But okay, to Chris's point, yes, I was the. We actually started. I met Chris in 2012, about 10 years ago, when I was he joined the rugby team at Rice. I graduated with my undergraduate from Rice in 2011, and I've been on the rugby team for 4 years. And really, had a good sense of camaraderie and team, team building, good culture in the team. And so I was really close with a lot of the younger players. And so as of 2012, I was still in Houston, working as a database administrator. And so I was just a young alumni, and I was hanging out, and Chris came in, and so we met then. And then a few years later, he came into physics. We had met in rugby, and so we knew of each other. And then Chris got a physics undergrad, and he was interested in condensed matter physics, which I was in a relationship at the time that he worked in her lab. And so for one of the summers, he ended up actually living in the house that I was living in. And that was the summer of 2015, whenever Ethereum was first kind of gaining traction and becoming well known. And he sent an email to a bunch of people saying, like, I have this idea for a company, come and talk to me about it. And literally, I believe the words were like, "You're smart. Why don't you just come along?" So I have a terrible inability to say no to things, or I used to. I've since learned that responsibility is like, it's like gravity. It goes towards gravity. It's just like when you say yes, responsibility just like it's lumped on you. So I just have an inability to say no, or used to. And so I came along and was just, for the longest time, we'd started out with 5 of us. We quickly dropped to 4. 3 of them, Chris, a guy named Matt, and a guy named Z. They were all Rice undergrads. And they started working on a thing that we called Sling Financial Technologies. And it was I thought it was reasonable at the time. It was basically, trying to bring merchants using a blockchain via, like ERC20 type contracts. So it was really early in Ethereum. And what we learned from that was 2 things. One, customer acquisition cost, you can never underestimate. Like, it's starting at the grassroots part and trying to get people to adopt is climbing a wall. And for people to be there's that wall, you have to have very good grappling hooks or very good grip to be able to climb that wall. And when we got to that, we started to scale it, and I'll never forget, Chris said to me a few years after we had done this pivot to what is now Topl. He said, before you'd explain the idea and people would say, "Oh, I think that's a really good idea," but there was never any follow-up, any interest. Now in this new idea, right, people will be like, "Oh, when can I have it? When can I do it? When can I use it?" And it's like they're eager right now. He's like, it's a complete sea change between knowing what it feels like to have something that failed and knowing what it feels like to have something that might be successful, but it's very different than something we know has failed. So it's in my opinion, it's what success looks like when you have actually experienced failure, or at least you know what not failure looks like potentially, or maybe it's a different type of failure. I don't know.
True.
But I went to him before that pivot.
True. Well, I'm sure.
Go ahead. I talk a lot, Steph. I'm sorry, my bad.
Well, so I'm sure that I can't see your video right now, so I can't see necessarily when you are done with a thought. But I wanted to say that I imagine bootstrapping a blockchain ecosystem has just thousands of things that you couldn't know prior to starting. And so that's I think a really interesting thing for a lot of people, that just knowing what that process is like, and maybe being naive a bit is a positive thing to have when going into this, not knowing just how crazy of a wall it is to scale. So yeah, I was just curious to know, what some of those humble beginnings, and then how it brought you to Topl, and then we can start diving into what Topl is, and I have some questions there. But please feel free, if you have another thought that you want to share in that direction, go for it. Otherwise, I'm going to ask about Topl and kind of start laying out some of the different pieces of what it is and why it is.
It's definitely grown over the years. I realize I never specifically addressed the statement that Chris made. At one point, I did go to, when that first thing was being built, I was still in grad school, and literally my title at the time was Voice of Reason, because I would meet them about month to month, and they would just tell me all the stuff they'd been spending their time doing, and I would just rip it apart. I would just ask questions and just try to understand more. I thought I was just trying to understand. I was just trying to make sure that they had thought everything through. And apparently that was valuable enough that they were willing to. So, and that's what eventually I went to Chris and I was like, "Look, I meet with you guys once a month, and we talk for 2 hours or something. This isn't, I'm not contributing anything to this company. You guys work day in and day out, and you're like let me go. I have grad school I'm worrying about. Like I'm not contributing anything. Let me go. And his response was, you're also not taking anything away at this moment. You're not drawing a salary. You're not, like a drag on the company. So there's no reason to let you go, basically. Um, so I don't know. I took that to heart, and then a few months later, they asked me to be the CTO, and then I started trying to do that in my between actually doing grad school and yeah. Um,
So Topl was founded in
mhm.
2017 with co-founders Kim and Chris, and I believe it kind of incubated probably from Rice first, and then there was an accelerator in Holland, and then back to Austin at Capital Factory, who we know well, and then a move to Houston, and specifically, I guess, pulling from the Rice talent pool. That's interesting to me. Where did Kim come on board? Were you involved, or were you aware of any of those processes before it being in Houston? And if so, could you just share any of that?
Yeah. So through I say 27, or like the date of like Topl's real founding was a little like it just happened over time. So I say the real date was the first commitment to the repo was in March of 2017. So I was like, look, if we got to pick a date, it was March of 17 because that is like we have a statement there. So that's why I say it's then. But that was actually before the other three like people that were in the previous. We pivoted from Sling FT into Topl. And so we started with the two original developers and Chris, and then that summer we hired Nick Edmonds as like employee number one technically, and then Chris had met Kim during that year or during that semester, like sometime I don't remember if it was in spring or the fall, and just continued to talk to her. And then we actually the other two original developers ended up leaving for various reasons. And so Kim came on board, and the three of us said, okay, we're going to we'll be the co-founders. And then Nick was basically our lead developer at the time. So whenever Nick and Chris went over to Holland with, I believe it was Brightlands was the name of the accelerator. And we had so there was a group called Iconic that we got some funding from out of Germany, and then there was a group called Brightlands that we got some funding from early on, basically to do research to really kind of go around and see what are the ideas of one of the I think early ideas that's still around that we still want to do is this idea of impact credits. So basically, just I always think about it as the generalization of carbon credits to anything good in the world. If you're digging wells or hiring more women or anything like this, right? You can make an impact NFT, and maybe we can make markets for that. So that's like that was one of the first early things, and so that was around the tokenization of impact, and so there was conversations and things being had in Europe, and then I guess summer of 2018 or like spring of 2018 was when I was asked to be the CTO. And that summer we hired a couple more developers, and so then it was myself, Nick, and these two gentlemen one named Yamir and Yammer. I'm sorry, Yamir. It was spelled like Yamir. It's Yammer, and one named Alex. And they were both really, really inquisitive and very, I don't know. We worked really well together for about that summer of 18 all through the summer of 19. And then when I came on full time, we started hiring more devs, and I actually learned how to become a software manager and all that sort of stuff. But I'd say one of the really early learnings, like I just want to say like why we pivoted. Man, it was a really good lesson to learn early because I still see people doing it now. I think I still see people struggling with this right now, and that is, it is very, very difficult to build a business and acquire customers on top of a foundation that's shifting, right? So that was because that was happening to us. We were trying to make our contracts and like build an application and then go out to people and like to merchants and things. But the underlying foundation of like Ethereum kept shifting, and it was very, very hard to develop in. And it was fine. It was like early days of Ethereum, right? It was moving fast, and things just take time to stabilize. But that's because I know that anytime something's new, you need to get it through its paces. You need to work out the bugs first. It really makes me nervous about like all of the energy, especially like L2s. As soon as like I know L2s are going to be a thing, they obviously are going to be a thing, but it really makes me nervous that like all of these problems, tooling and working out the bugs and finding all the vulnerabilities, like those things only take time. They take time, and I'm so worried that the clock is going to run out, and someone in a position of power is going to be like, criminals use this thing. This is bad, and then we're going to like lose this potential. I don't know, city on a hill that we could move to.
Well, hasn't that been the narrative from the beginning? And isn't that kind of, I mean, what are the things you said a bunch there, and I appreciate that background, because I think that's a helpful thing to point out, is that so many ecosystems and layer ones have sprung up, and layer twos, and different ways of bridging and connecting. And when you're on shifting foundations, how does one know to commit to a particular direction when the underlying thing may have a different consensus mechanism a year or two later? And so that's it. It seems deliberate in Topl's case to at least launch a token or tokens when the time is right, when when you're ready to decentralize governance. And that's something that I want to talk on as well. But I'm just glad that you pointed that out, because I think it is worthwhile noting that we're in that stage that has a lot of things still to be understood and figured out. Before I let you respond to that, so Topl's an impact-focused blockchain that's trying to help entities track and tokenize and transact positive impact into the world. And you could use this phrase, impact monetization engine. So could you kind of talk about what the impact monetization engine is? Because I think it explains the why and lays the foundation for then the what. What is the technical things that have to supply that mission?
Yeah. So it's really funny you say that, because I recently, actually, I think in the discussion we had about the UTXO Alliance, kind of clicked in my head that mission, vision, values should just align to why, what, how. And I like that, because then that means that values are how you do something, right? Which to me makes a ton of sense, right? Like the way you choose to act in the world are your values. And so then I work backwards and I say, okay, well, the what then is your vision. So like what you're doing is the vision, and it's the vision of your mission, like how to achieve your mission. And then the what you're doing is, why are you doing this thing? So then therefore mission must be why you're doing anything. So with that kind of framing in my mind, I like to say, but I by no means want to, this part, I'm just going to, this is like something currently under discussion. So we will have to like listen to this part and see if everyone's, I just don't want to say something that people are just like, that's not the mission of Topl, and blah, blah, blah. So like, I'm going to say my piece, but I will have to have like other people.
This is your personal opinion.
So
yeah, okay.
In like my opinion, and the mission that I would like Topl to pursue, is one of, I've said, make it economically feasible to do good in the world, right? Or another way of saying that is align short-term profit-seeking behavior with long-term sustainability goals. And then a final vision of that is, like I said earlier, this idea of a closed loop economy, or like closed loop economies, things that are reactive and don't just, your cruise control in your car is a closed loop. It's a closed loop system. right? Whenever your speed goes above the whatever your set point is, you slow down. When your speed goes below the set point, it speeds up, right? You don't just set the cruise control and then it just accelerates ad infinitum, because that would be silly, right? That's not what that is considered open loop, right? That you just put an input in and just like let that input keep going. But if you modulate your inputs to like come back to your set point, your desired outcome, that's a lock. That is a closed loop, and that can be made stable. It's not necessarily stable, but they can be made stable. You can't make an open loop system stable. It just like it's like a control theory thing. I don't, again, self-taught control theory grad school, so maybe someone like a double E might disagree with me there, so I'm going to hedge. But I'm pretty sure mathematically there are only special types of open loop systems that are stable without any intervention. But in general, most open loop systems are not stable on their own. Go ahead.
So from what you said in terms of aligning short-term profit seeking with long-term sustainability, I don't know if that's debatable. I don't know. And although what we see in the world may not align to that belief. And so the point is, how do you actually build a system that aligns those things together, the short-term profit seeking with the long-term sustainability? And I think that leads us into, okay, so what is Topl doing in order to address those things? Tell me about Topl and how you're thinking about it from a high level.
So I would characterize it a little bit differently to say that we want to create an impact monetization engine, and to create that, we need to then think about what are the like pieces or the components that would go into that, and then make sure that the underlying system can achieve that thing,
Brilliant.
that monetization engine. And I think it's important to target this idea of an impact monetization engine. One, because my vision, if I said the mission is to align short-term profit seeking with long-term sustainability goals, my vision is positive, lasting impact, right? I want Topl to make a 1,000-year protocol, right? I want us to, as humanity, like this first thing I'm going to launch next year is not 1,000; it's a 10-year protocol. I'm willing to put like my reputation and everything that I've done over the last to say that nothing. I think this protocol can run for 10 years, right? It's honestly, I have plots where I can show you that it's actually more secure than Bitcoin. In certain regions, it actually keeps its security it maintains a higher level of security than Bitcoin at the expense of less accessibility, because it's proof of stake, and proof of stake necessarily is a little less accessible than proof of work, right? But to say that like everything about what we have done has been to try to like make honest behavior and like good the things that like, that's why our taglines are right now has been like build good, because it's not just impact and the applications that you put on the ledger side, but it's also the consensus and how you actually distribute that or do that. Because a little bit of a tangent, in Ethereum, in my opinion, is not fully doesn't, even in its proof of work sense, didn't replicate Bitcoin, right? Because of the account model. Because yes, you could say that you are a public member of the ledger. Anyone can create transactions. Anyone can verify those transactions. So public. I'm referring to a diagram that we haven't gotten to. But on the right side to the consensus, it's not public. It's actually pretty private, right? Because you have to have a machine capable of putting out, hundreds of mega hashes or giga hashes or used to hundreds of giga hashes, and now you have to have 32 ETH, which is like over almost $33,000, 34,000, something like that, right? So like the consensus side of Ethereum is completely closed, or like dang near closed for a lot of people. Yes, technically it's open, but like it's not accessible. So that means, and so if you look at the construction of Ethereum, it's almost like it's just an API request. Your transactions are just an API request that you sign, because that's what MEV is. MEV just, it's like saying, hey, miner, please, or hey, block producer, please do this for me. And they're like, I'll do whatever I want, to some respect. And I don't know, it's just that willingness to like we started this conversation, me saying that like blockchains hold the greatest potential to revolutionize the human's relationship with trust in society. And the first thing we did with like once Bitcoin was a thing was build Ethereum, and it took off because it actually does exactly the opposite of that. It takes away the user's autonomy and it gives it to a small subset of people. So in my opinion, Ethereum is just a recreation of like the capitalist stuff that has like gotten us into the mess that Satoshi was trying to get us out of. So to me, it's not just about what the applications and things you can do on the impact monetization engine, but about more addressing the lower line things of how can everything you do be honest, accountable, and like secure. I want to promote this idea of quantifiable security. Right? Businesses should, they have risk assessment, they have risk tolerances. They should know that if I want to, I have a certain level of trust between me and this other entity. That means that if they act and don't fall below a certain threshold of like security in all of the transaction, all of the data they send me, all of the transactions orderings they send me, all of the ledger transactions they send me, those are the things that will fundamentally allow you to quantify your relationship with that entity, and therefore like conduct business in the digital world in a way that replicates closely the physical analog, which is we are able to do business physically because we see each other. There's so much communication that happens through our body language and like just knowing someone. In the digital realm, we don't get that. And so people are just, like I said, taken advantage of. And so I have this whole idea of how I think the key thing that blockchains introduced is this idea of like symmetrization. So we can go into that. It's like a little technical. But I think Satoshi was the first one to realize how to symmetrize consensus. And so the revolution of Bitcoin was, again, in my opinion, not necessarily electronic cash. Electronic cash is great, but BitPay had already realized electronic cash. It was Satoshi's vision, or Satoshi's like contribution was Adam Beck's proof of work for spam prevention used for a consensus mechanism. And then they layered a ledger of electronic cash on top of that. And in my opinion, that makes the most sense in the world, because if I want to test that the consensus mechanism makes sense, I'm going to put the biggest honeypot I can on top of it, and that honeypot is a currency. So now if my honeypot stays secure, I know the consensus mechanism is robust. And it seems like everyone got a little caught up in the electronic cash part.
That was beautifully laid out. So I do want to get back to the symmetrization.
Symmetrization.
I hope it's not as more technical than saying symmetrization, more technical than me having to pronounce it. But so Topl's in the current form building a 10-year blockchain because you're aware of how things need to evolve for the next 1,000 years. So in this 10-year blockchain, what are some of the other high-level aspects? You pointed out security, and you think it can rival Bitcoin or surpass. What are some of the other features from a high level that are part of that 10-year plan? Let's just use 10 years. And like, how do they, what would you name some of those other things to be?
Thank you. That's a good question. And before I get into, I will say, even though I'm calling it a 10-year protocol, that's like I use that term because that's actually something the Navy uses. The Navy, when they build ships, or at least the US Navy, when they build ships, they rate them by their like capacity to extend them, right? They give them like a lifespan, and they leave extra room in the hulls, because the framework is the thing that's going to take forever to, like, you can't change that quickly, but you can change some of the stuff out in the middle. So that's when I say 10-year protocol, I'm just saying I'm going to build enough extensibility into it to try to last 10 years. But maybe we actually did more than that, and it could last 50 to 100 years. What I'm really trying to get at in that is saying the jump, though, is from 10 years to 1,000 years. Because if we go to 100 years in the middle, that's kind of like a stopgap. Like, if we can actually make 1,000-year solution, like, what do you think? Interplanetary latency is something you have to think about when you think about 1,000-year protocol, right? Generational, like, how do I give my keys to my kids kind of questions when you think about a 1,000-year protocol. Like, how do you transition countries, right? Is there any countries on the planet that have existed for 1,000 years, like currently in existence? So like, those are huge questions. Maybe they're too big questions. I don't actually know, but I'm willing to say I'm going to work on a 10-year protocol for now. And maybe in that 10 years or 20 or 30 years, maybe I'll be 80 and still saying the same stuff. I don't know. I hope, because that would mean that I've just gotten my entire life in this space that I really love. But yeah, I don't know. I think we can answer some good questions and make a lot of headway now. But the biggest things where blockchain could help human, like species advancement, is if we can actually make something that we think could last 1,000 years. Okay, the 10-year protocol though.
Yeah, that was beautiful. So
yeah, so
yeah.
We're currently calling this the Tetra version, which are named after hypercubes. So the version 0 of our blockchain was called Monon. Version 1 of the blockchain was called Dion, and version 2 of the blockchain is called Tetra.
Is there a nomenclature theme here, just in general, for how Topl names things?
So Topl is actually from the word. It's just a play on the word topological. So it's always supposed to be math themed. All the external products are supposed to be math themed. So that's why our wallet is called Ribbon. Our like GraphQL service is called Genus. Our SDK is called Bramble. These all sound like silly things, but they actually they're like math terms. We've mixed between like topology and graph theory a little bit. I'm not super. They're all just math terms broadly. They're also fun little things that you can pull vowels out of, and they're cutesy. So it has worked for us so far. Yeah, how do you market? It's an important thing.
Totally.
So, like you said earlier about the taking a slower approach, right? This, like, how do you actually make this impact monetization engine? How do you and going about it, like only releasing a coin once we think we have something that can actually be stable and we can. I've always been terrified of like decentralizing, or like having the coordination problem of like having to manage a huge community. Just seems like it could suck all the air out of the room. Like once you're willing to take on that problem, you need to have an entire dedicated team, or the team you currently have is going to become that team. You're going to, like, development is probably going to screech to a halt if you don't have a dedicated like relations team. So since we've been tiny, like this time last year we had 20 people, and that was the most we'd ever had up to that point. Now we're at 40, 43 or something like that, which is again the most we've ever been at. So we're growing steadily, but we've been, relative to what I believe we've accomplished, we've done a lot with little. One of the very first things we did was, and the reason that it is in line with like this more conservative approach of not decentralizing before you're ready, but also the original version, the Monon and Dion versions of our mainnet don't run a secure consensus algorithm, because we've always been like sustainability focused, and so I was never willing to use proof of work, even though it is a really elegant, secure way to, if you can get enough hash power to secure your chain. But we've always been proof of stake, and so we identified Ouroboros as a mechanism we wanted to replicate early on, and so that's what we spent a long time, and then we actually made a change. So one of the biggest changes is this idea of regularization. So I like to say that this new version of Topl will be a modular layer 0 event DAG blockchain, a modular layer 0 blockchain using regularized Nakamoto style proof of stake with an extended UTXO smart contract system and native custom assets. So that's a lot, right?
Okay, pause. Can you first just say a brief bit about why Ouroboros, and then can you go into the modular consensus UTXO, extended UTXOs part of it?
So yeah, one of the things I identified early on is that these distributed systems are like kind of two protocols composed together. There's a consensus protocol and a ledger protocol. I said that a little. I kind of implied that earlier when I was talking about Bitcoin, right? because the consensus part, and the consensus is just two things. It's leader election and chain selection and validation, block validation. But block validation should be like a rote thing. So chain selection and block selection. I'm sorry, chain selection. Leader election and chain selection. Those are the two components, primary components of a consensus mechanism. And then on the ledger side, it's primarily just read and write. It's the ability to make transactions and verify transactions. But on the and it's really pretty much the same. That is what it's read and write on the other side too, right? Leader election is just the write part, and chain selection is just the read part because you need to know what you're reading. But so Ouroboros we identified as on our consensus side really early on. It was actually one of the original gentleman who was around. His name was Matt Kendi. He had followed Cardano and had an interest in Ouroboros, and so he kind of handed it off to me. And through reading it, I really wanted the whole idea behind Ouroboros was to replicate proof of stake, or I'm sorry, replicate proof of work in proof of stake. Right, that was literally the goal. The first security analysis of Bitcoin was published in 2015, I believe, by Garay, KIS, and I always forget the L, so I apologize. GKL, I forget who the L is. But that Bitcoin backbone paper was the first like real security analysis of like what makes Bitcoin secure. And what it means is they ended up deriving some statistical bounds on how to do it, but they also developed a whole framework for how to analyze the protocol. Then Ouroboros was taking that analysis and then figuring out how to replicate it in an algorithm, right? And they did a bunch of weird stuff. There's a different version. There's been multiple versions of Ouroboros over the years. I brought in a gentleman in 2018 who was at Rice with me, and my first question was him was, Aaron, please, make a simulation of Ouroboros, and like we just need to learn it because there's two things you need in Ouroboros. There's a VRF, which is a verifiable random function, which is how you do the leader election, and there's a KES, and the KES is how you verify registrations. It's how you know the person was eligible to actually make the block. There's like a lagging window that you look back. So it's updatable in that sense, but it's not as updatable as Bitcoin. So. But so he started doing that, and one of the first things he realized was when he got the whole testnet working was that there's this thing the Cardano community calls slot battles, right? When you're and it's why Bitcoin goes so slow is because when your block frequency or your block interval is much greater than your latency, your network latency, the probability that any given election is a unique election, like there's only one, is pretty high, right? So ideally, the way you advance the chain is there's only one block at a time. And BFT algorithms or more traditional algorithms do this by like, we all talk a bunch and we decide who's going to be the one to propose. And because we talk so much, we know we're not going to debate that one person. They're going to put the block, we're going to accept it, and we're going to debate the next round, right? And in a Nakamoto style, it's a race. It's to see who can get the answer first. And even in proof of stake versions, it's still a race. So in the proof of stake and proof of work Nakamoto style, it's a race of a sort to see who can get that thing. But then you need to who can get the next block. But then you need to write out what is the statistical probability of a collision of two people getting the block at the same time. And that's why proof of work with really long timescales is so good because the latency is very small compared to the block interval. Sorry, I went into like details, but what we did was we regularized. Okay, we went into we instead of having a static threshold, we allow the threshold to vary over time. It varies since the number of blocks or the number of slots, the time since the parent block. So in Bitcoin, there is every trial is independent, right? It doesn't matter when the last block was. If you could have just gotten a block. When you test, you could win. You could pass the thing. But in our blockchain or in regularized, in what we call Ouroboros tacticos, so regularized Ouroboros, the probability to create a block immediately following a parent, so like you have a parent and the slot right after that parent, it's not exactly zero, but it's pretty close to zero. It's like, it's really, really small. And then the next slot, it increases a little bit, and the next slot it increases a little bit, and the next one a little bit, and then it's a line until some max value, and then drops to like some constant, secure value for like bootstrapping. But that ability to just like kind of shape what it results in is it shapes the block time distribution. And there's some plots that we recently put in a paper we submitted, where compared to the Ouroboros-Prowse, which was, like I said, made to replicate Bitcoin, we, for the same level of security, improve on the 99th percentile like latency, the 99th percentile event period by a factor of 6. Right. So what all that means is a very fancy way of saying, like, Cardano would expect given their current configuration, would expect a 3-minute stall twice every epoch. So twice every 5 days, their blockchain does not create a block for 3 minutes. Our protocol would have a 3-minute stall once every decade, or something to that. I don't actually know the things, but it's something to like a year. It's not every 5 days. It's something to like a year, or 90 days or something. I need to actually go do this. But that's that reduction in the, like, it scrunches the. I don't know if you literally have this plot in my head, but the block time distribution of Bitcoin and an Ouroboros-Prowse is like an exponential. And the problem with that exponential is that the most likely value, the peak of the exponential, is as you go to 0, and the expectation value of that exponential is non-zero. What Tacticos does is it aligns the most likely value and the expectation value, right? And it just means that now it becomes a much easier way for the honest participants, because the honest participants have to suffer latency. They know they have to suffer latency. So because I know I'm going to have to suffer latency, we literally did it on this call, actually. Because you're going to have to suffer latency with me, we just slow down. And we don't put as much information on the channel because we know there's a little bit of buffer, and we need to leave time between whenever we do stuff. And that's literally all we did to the consensus algorithm. But that it radically changed the security properties. And it's really amazing, actually. Like like, this is literally the whole basis of, like, I think there's no reason blockchains and distributed protocols can't map to physical models. Like, there's no reason a distributed set of nodes can't have a temperature of like a certainty. But yeah, I don't know. It's those like slow things,
okay,
like just like reevaluating everything that just is the premise of how we achieve this impact monetization. Sorry, go ahead.
Yeah, so it feels like you're putting two things. You're trying to come from first principles and ask the questions of why is this needed, and because you already have a clear vision of what you want to do, it really informs on how you do it. And you're answering that question that I asked, which is great. And then the other part is, I'm just curious, like, how far in number of years, or in bringing Topl to where it is now, what has the open source of Ouroboros and other tools been in the development of new protocols? Is it just absolutely radical for being able to import a protocol and build from some of those beginnings? Can you just talk a little bit about that? And because open source is obviously one of the main driving factors of blockchain development.
Yeah. So participating in open source and having everything be open source has been like a huge benefit to us, right? Because, like I said, we're on or as I alluded to earlier, we're on the third coast, and that just has always meant, like, we don't have the right. It's hard to find the networks, it's hard to find the people to get that. Those wisdom is really hard to come by. So at least through open source, I'm able to like develop my own wisdom by seeing what's the information, what are other people sharing, and so the openness of the Web3 community and the generosity of people that like want to align with building a better like infrastructure for human advancement is heartening and humbling, and I don't know, I want to be a part of it.
Yeah, I think there's something deeply humble about, this is the way I choose to look at it, is part of the open source is almost admitting I don't know everything, and here's what I know. And if you know something, please stand on these shoulders and run with it. And that's how I choose to view a lot of what open source is. And so it's just interesting to hear maybe that point of view of it. Okay, I think we have a lot more to say, and so I want you to turn your attention to we're going to jump back once or twice and talk about the modular extended UTXO, some of those other aspects of Topl, just beyond Ouroboros. If you can go back to that thought and then build off of it.
Yeah, definitely.
Are we on the same place in the consensus?
I think so. I hope so. Yeah. So the other side, the ledger side of the blockchain, we early on in Dion tried to make a thing that we called the chain program engine. It was basically supposed to be. It was kind of like Qdums, or I don't know, it was this a little while ago, but Qdums, like account abstraction model. But we kind of went the other way. Instead of making accounts that went to UTXOs, we had users would still use UTXOs, but they would target them a little bit. I guess it was more like an account now I think about it. So yeah, it was very much like an account abstraction. It was a single way to come in and be directed to a UTXO that needs to be spent, and would actually allow that a more similar like account type model. Once we'd done that, we also enabled, or we built in native assets, the ability for users to issue a custom token on the blockchain. We only have our Dion protocol only allows for fungible tokens at the moment. And I say that specifically because going into Tetra, into this new protocol, we looked at the two things that we stumbled in Dion, right? Like I said, you don't know what you don't know until you want to, or you don't know how to use it until you try. And then we built the thing, we tried to use it, and it was clunky and it was rough. So then we're like reapproaching it.
Again, Dion is the second iteration from Tetra to Dion, and this is launched or current, or
Dion is our current public version, but we control it is technically permissioned. We control all of the stake because it's insecure to decentralize. It runs NXT, and so NXT is vulnerable to what's known as a long-range attack. So we've controlled all of the stake, but we've offered it as like a BaaS service, or we have this, like you mentioned earlier, this traceability as a service, or this RAS as a service on top of that right now, so that we can start exploring. Really, my approach has been, an MVP should be it's an end-to-end test. It's the smallest possible triangle along the pyramid of like all the things you need to do. An MVP should be the smallest sliver of that triangle. And so we tried to do with Dion. Dion, right? It's in production, it's deployed, but we needed people to use it to then tell us what wasn't good enough and what needs to be made better in Tetra. So like I said, the usage of the contract system was not great. So we now we embraced we followed the lead of Ergo and Cardano in utilizing an extended UTXO smart contract system. And just in my opinion, I actually really like it, because now that I've thought more about it, instead, the best way to describe it is an extended UTXO smart contract system in comparison to an account model smart contract system is one where the account model is like a robot, that it's a contract or a robot that holds a bunch of tokens. So it's like a bank. You go to the bank, you ask the bank to do something for you, they do it, right? Whereas an extended UTXO smart contract system is more like cash with a little robot attached to it, right? Because the UTXO instrument is a bearer instrument. You are the user is responsible for maintaining the UTXO, which is why it's hard to use in a in a world computer, right? Because then that means each like you have to build out the paradigm for how you expect users to coordinate their computation and participate amongst themselves and the consensus operators. I think we're at the point now that we've developed enough, or we've seen enough of in my Ethereum, I really love Ethereum for it being a sandbox. I am terrified that Ethereum is going to win out, or like win out and like be the thing that takes over Web3. Just, I don't think that would be. There's just like there were things made about Ethereum that bug me that I think we can address in the UTXO system, right? That it's more cumbersome to not have a single entity where that addresses many pieces of state. But if I can actually automate and algorithmize like the coordination of how to do computation in a UTXO smart contract system, then that's what we've gone the path we've gone down. So we're much more, in Ethereum you tend to use one key, and even though you have a whole mnemonic, you only use one public key, and you never really, you might use a couple of them just because you want more accounts, but you always sign with the same secret key. For the most part, you sign with the same secret key. And in Bitcoin, they like have post-quantum security by like you're supposed to jump from account to account. And my thought is, why I would prefer that like post-quantum security of Bitcoin to jump from account to account, but now I need to like coordinate. I need that problem of how do I know where to find the data? How do I know what computation to do? How do I coordinate with you to get your signature and all that sort of stuff? And so one of the things on the ledger side that we've been exploring is taking the lower three levels from the BIP44 spec. So BIP44 is like a specification on how to derive a tree of keys, and it's specified with 5 levels. That was the original, and so that was the original thing. And I'm trying to stick to the 5 levels because that's what hardware manufacturers and things have like built in or assumed for a while. The first 2 levels are kind of already assigned for. They're for different things. But so the bottom 3 levels are somewhat up to the chains. Like they say there's a spec for them, but in my opinion, they're somewhat up to use to. But then let's just use those 3 levels. Those 3 layers, or those 3 things, are now a Cartesian. It's a Cartesian volume, and all the Ethereum try, in my opinion, it was a path to get to storage and code. To computation is just code and state. So all the address and the try is like point you to a repo where the code and state lived. Why does the code and state need to live like on everyone's computer? Why don't I keep my own code and state? Or you or Steph, like if you and I have a contract between us, maybe you and I both keep a copy of that code and state. And yes, we have the data availability problem. I'm not going to argue that. But as it turns out, so does Ethereum. No one can get away from data availability because that was the first symmetrization that happened. P2P in the 90s or early 2000s, that was the first symmetrization of like information is the first like thing where we can have a client-server relationship. We can have a leader and a subordinate, and that leader and subordinate relationship, or a main subordinate relationship, can at times be like used against you, or maybe you don't have full insight, and that's why P2P became a thing. Now we can like cryptographically share amongst a set of like permissioned peers. We can all share data in a way that's like verifiable, and that was the first symmetrization, and then we go from there. I'm gonna refer to another thing that I don't know if we're gonna actually have time to get to, but I've been we can have this idea of a hyperdimensional event DAG, right? There's no reason that transactions should only be able to spend other output or like outputs, because all in a UTXO system, UTXOs, maybe we can in a second go to maybe explaining, because we haven't quite done that, or I haven't done that yet. I've just been saying the term. But a UTXO stands for unspent transaction outputs, right? And that's important in the construction of Bitcoin because if your transaction output is unspent, that means it can be spent, right? And that's literally like saying that if I had it, but like a $5 bill in your wallet is unspent because you own it, right? Like the fact that I have it means it is unspent. So that's that UTXOs, I called them bearer instruments earlier because that's kind of what they are. If you have the right to spend it, you own it. It must exist. If it is spent, it does not exist, and it's how we solve the double spending problem. Because if it doesn't exist, then it can't be spent again. And because it can only exist once, and as long as you ensure uniqueness that it can only exist once, then you solve the double spend problem. And that was actually one of the very early learnings I realized, is that I did not put enough care into making sure you could only make a transaction ID once. And that was a headache and a half.
Can you compare UTXO to a count model in a simplistic point of view and just be able to give people a way to catch up visually in understanding it? What I'm thinking of is the pass down the line idea that you had.
Yeah, so we've been working on this this idea for how to communicate in kind of like 5 levels of education. And the easiest to me for visualizing like the problems that become apparent in a UTXO or in an account system versus a UTXO system is a visual that focuses on the idea that in an account model, it's a public mutation of state, whereas in the UTXO model, it's a private mutation of state, right? So let's go into the example then. What do I mean by a public mutation of state? So imagine you're a little kid, right? It's just like, Alice and Bob, just little kids. They're talking to one another. Alice tells Bob, "Hey Bob, I'm going to tell you a secret." And so she tells Bob the secret, and Bob writes it down on an envelope or a piece of paper, and then puts it in an envelope, and then gives the envelope to the teacher, Diane, right? And Diane can open the envelope, and maybe she sees exactly what Alice said. Maybe she sees something a little different, but with only Alice having to tell Bob, the chances are Bob wrote pretty close to what Alice told him to write, unless he was being malicious, right? But you can imagine if you introduce Alice and Bob and Charlie and Foster and Aziz, or like you just use the more people you add to that chain that Bob has to go tell each kid, the greater chance that when it gets to the end, and whomever's at the end gets to write it down on a piece of paper and put it in an envelope and give it to the teacher, the more people you add along that chain, the higher the likelihood is that the end result will be incorrect, will not be the desired thing that Alice asked for. And that's the key, my key insight into trying to make this thing, is that in the UTXO system, Alice, back in the original thing of Alice and Bob and the teacher, Alice would, instead of telling Bob what she wanted and Bob writing it down, Alice would write it down herself, put it in the envelope, sign the envelope, and then give the envelope to Bob. And then Bob doesn't get to do anything, because if he opens the envelope, then when he gives it to Diane, Diane won't accept it, or to the teacher, she'll just reject it because it's open. So instead, he just takes the envelope as it is, looks at it, makes sure it's good, like it's got the signature, it's got the right size, color, whatever, and then says, "Okay, I think it's fine." He gives it to the teacher. Right? And so, same thing. Since Alice wrote it this time, though, the teacher probably knows, or Alice has a pretty good guarantee that the teacher got what she asked for, right? Because no one could manipulate along the chain. But then it extends, right? When you add all those extra kids in the line, that same UTXO just gets passed from each, or that same envelope just gets passed from each kid until it finally gets to the settlement or the teacher, and the teacher opens up the thing that was originally done by the participant at the beginning. And so it means that it means that account models might be good in like an interface to in a one-off, in like a one-to-one kind of thing, because they're very efficient. They're very efficient. I will never argue that. They're very poorly optimized for extension, though, right? UTXO systems are much better for extension, and we already see this because L2s and
because why?
Encapsulation.
It's because when so what do you mean?
I mean, it's just that the encapsulation is,
or not your output,
not your outputs, not your outcome. You don't get to control your in the original example where Alice just told Bob and Bob wrote it down, right? Alice could have alternatively taken a sticky note, written her message, and then signed the sticky note. But the sticky note isn't what the teacher's asked for. The teacher wants the envelope, right? So the sticky note in this Ethereum idea is like the thing that you generate with MetaMask, right? And you give the sticky note to Bob. Bob is the block producer. Bob in Ethereum has the ability to do MEV. So if Bob wants to put his own sticky notes in front or sandwiching your sticky note, he can. And then he can put it in the envelope and he can give it away. But in the UTXO system, in the other example, by Alice, even if she had a sticky note, she then has to create the sticky note. She doesn't get to sign the sticky note. She could, there's no reason to. She has to actually make the outputs. And then she signs the outputs. And so that's the important part, is that because the outputs are the things that go into state, they're the actual things that get read, and they're how the state machine progresses. The outputs are what the state machine replicates. That should be the important thing. Cool. The outputs are what the state machine replicates, and all Ethereum and Bitcoin and Polkadot and all these systems are. We call them fancy things. They are just they just realize state machine replication, because computation is just a state machine, and we just replicate it massively. So, and I think we already see this in other places too. People see that encapsulation of UTXOs and the signing, getting a signature on the exact thing that is in state is whenever you hear things of Ethereum will become a verification chain or like data availability, or it's like only about data availability. That's what they're talking about, is that it's only the signatures and only the stuff that needs to be verified and not the actual like state itself.
That was I really love that visualization, and it is helpful. And I should mention that not your output, not your outcome is your saying, it's not mine. So I didn't mean to try to take credit in any way for that cleverness. James, as we get close to wrap up, can we do some 2-minute rapid fire? Could you go through symmetrization, registry as a service, and traceability as a service?
Yeah, definitely. So the idea of the symmetrization, it is a bit of an involved idea. It takes a little while to like get all the way through, I think. But the premise of it is that fundamentally, I use it to promote why our TAM, why this 2 label system is important, because that's where I realized this. And it's just premised on the fact that like in the 90s we had symmetrization of P2P networking of data availability data availability, and then the next thing above that is consensus, is transaction ordering. So once you have the data, the next thing you do is you need to be able to order the manipulation of that data. And the symmetrization of that was Nakamoto, was the Bitcoin paper. And the next thing above that is ledger, in my opinion. And so how do we symmetrize the ledger relationships in such a way that the assets, the asset behaviors themselves can't be used in a like leader subordinate relationship, or like a client server model? Because I think that's really what I'm trying to avoid, is everyone needs to be equal, and yeah, I want equitable. I want what is the term? Egalitarian. I think that's what they keep trying to tell me to say. I'm just not very used to that word. So, but yeah, like equal, equitable, egalitarian. That's what we're going for at this layer. That's what blockchains. That was the promise of blockchains, and that's what I'm trying to do. Okay, so I can go to TAS and RAS.
Yes. Yes.
Yeah. So TAS, traceability as a service, and RAS, registry as a service, really are 2 of the first, just initiatives that I wouldn't say they are the only thing Topl wants to do, but being on the Third Coast, folks, one of the questions we got a lot was, ARR, what's your revenue? And so we had to go about, how do we actually use this thing? We can't just, build a cathedral or the Taj Mahal. We have to build something that's useful. And so like concurrently, while we're learning about Ouroboros and doing all this other stuff, we're also building a traceability application. My first introduction to software development was actually because I hired a developer to build it for me right when I came out of grad school. I unfortunately really didn't know what I was doing, and I set him up to fail. I willingly admit I completely and blindly set him up to fail, and I was asking him too much, and I didn't know what I was asking him, and he quit, which was he should have done. And then I had to take over the job and realized, wow, I really don't know what the heck, like this. I was asking him to do things well beyond his. So then I just had to buckle down, and I had to learn JavaScript and all this stuff. So like that was my first. But in that, I learned so much about how people actually want to use it. So traceability and RAS are just our like first two initiatives. I think traceability, because people are blockchain and supply chain, and so they're like chain. It's easy for them to see how it would map together. And so it was really easy for us to say, especially because we want to be impact focused. So it's really easy for us to make that connection for people, and they could see immediately the value of having a traceability application for supply chains. And then the registry as a service is the first step towards these impact credits and these impact credit marketplaces that we ultimately were the original vision of Topl. But I'll just take a little bit longer to go one step further and say that what I love about the Succinity UTXO smart contract system, though, is literally blank as a service is possible. Literally anything that you can do as a service, you can couple to an UTXO smart contract system, right? How granular you can get with like the contract you're able to invoke on our system at this time is, that's the definition of the trust spectrum. But the ability to be able to do blank as a service and just do micropayments, right? To just have a subscription and say like, oh, well, if you're going to host this data for me, I'm going to check that the data is there every hour. If the data is there every hour, I'm going to deduct, or like I'll let you spend some amount of money from me, or something like that, right? It's just these little micropayments to do anything as a service. You can do those really easily with Xfinity UTXO smart contracts, and I haven't seen that ease in account-based or like EVM models, as at least to my knowledge. I could be wrong there though.
Tell me a little bit about Rice, what's going on right there, and like the university course that you're teaching.
So the course is actually through I think if you go and troll YouTube, you can still find the original idea for Topl. Whenever Chris pitched it, was at a thing called the UBank conference, EUBANK, and that's hosted by the statistics department at Rice. And so we found a couple of champions in the statistics department really early on, and then actually where Kim was getting her PhD in statistics. So we've just, like I said, had a pretty close relationship with them. So it's actually, my class is offered by that group in the statistics department, which I kind of find a little funny. I say jokingly to people that I'm a physicist teaching a blockchain course in a statistics department. That just tells you like how early we are in this whole thing. But I don't necessarily think it's the wrong place for it, right? Because we do fundamentally all this idea of like quantifiable security. It's about quantifying your risk and knowing what you're actually doing. So I do think that like interdisciplinary nature that Rice has always really promoted and been kind of excelled at is really, really interesting. I found some really weird Rice connections also, like it's really funny, the type, like Brian Armstrong went to Rice, the guy who ended up making the guy who wrote R, like this is even at Rice, the guy that or there was a gentleman who came up with an approach for making DSLs, which is like really useful in Scala, which is the programming language you use. He was from Rice, and so it's been this very interesting amalgamation of different Rice connections that I've discovered over the past few years. So I don't know. I think the ability to just explore and kind of have that willingness to try new things is what I think Rice is getting right. I think there's been a lot of energy from the students as well. This is the third year I taught the course, and the fifth time. We had 3 sessions of a 1 credit hour and 2 sessions of a 3 credit hour. And we had, a dozen, maybe a little over a dozen students for the first 3 semesters. We had about 18 last time, and then we had 42 this semester. And there's a good blockchain club that's arisen. So I think there's a lot of like good interest there. And I'm really excited to connect in Austin. There's, a really good DAO, like a city DAO, ATX DAO. And the UT Texas blockchain, it's not the Alliance, it's I don't know. There's a group out of UT that's really active in blockchains, and so I'm hoping that I can use my proximity to UT and my connections at Rice, and we can just make a third coast blockchain powerhouse. We'll see.
Mm-hmm. Yeah, I love that. So, James, I really appreciate your time today. Hopefully, we captured everything with a little bit of technical difficulties, but fascinating discussion. I feel like I could interview you for another few hours and we'd scratch the surface. Wolfram Blockchain Labs is a huge supporter of Topl and the work that you're doing. We work together in the UTXO Alliance, and more will be coming out about that. For now, happy holidays. Appreciate your time again, and thanks for coming on, and hope to talk to you again soon.
Thank you for having me. Really appreciate it, Steph.